Hey guys, hi everyone. Good morning everyone. Good morning. I hope I am audible as well as visible. Am I? Hello guys, hi everyone. Good morning Smita. Good morning everyone. Good morning Somia. Good morning Sagar. Good morning Arka. Hi Najam. Hi hello Adil. Hello Usha. Good morning. Good morning Pradnya. Good morning everyone. Good morning. I guess I am audible. Perfect. That looks good. So we'll be starting our session in 1 or 2 minutes. Let's wait for few more minutes for rest of the people to join, and then accordingly we are going to start our class. Good morning, Saeed. Good morning. Walaikum salam, Sadi. So let us set up the environment in the meantime. Today's class is going to be one of the very important classes. Good morning, Priyanka. Please make sure that you stay up till and do not leave the class in between. I can guarantee you one thing, that there will be at least 3 to 4 questions from this particular class in your interviews. That makes this particular session a very important one. So let's make sure that we stay up till end and try to understand everything that needs to be understood related to this particular class. Okay, so let's wait 1 or 2 minutes. I can see people are joining. As of now, only 15 people have joined. So let's wait a few more minutes for rest of the people. In the meantime, let us set up the environment, and let's also do one thing. Let's try to understand what our today's class agenda is. Okay. So we are already in our JavaScript. We have discussed almost 10 classes in JavaScript. We have completed 10 classes in JavaScript, and we have completed synchronous JavaScript. We have completed DOM, and now we are going to create a new folder here because we are going to learn about asynchronous JavaScript. Okay, and we are going to understand what this async JavaScript is, what are the different concepts, and everything that needs to be understood related to asynchronous. That's what we are going to learn in our next 3 classes. My target is to complete our JavaScript in next 2 to 3 classes only, and with a project of 1 class, which means 4 classes maximum to JavaScript, and then we will start our React. Okay, but provided if I see people joining, I can see only 15 people here, which is not acceptable, right? So what have we done until now? Let's start our class. First of all, I'm not able to move. I have some issues in my left leg now, so that's why I won't be able to move that much. But let's try to start our class now. Okay, shall we? Shall we start our class? Shall we start our class? I can see only 15 people here. What's the issue? Why are people not joining? Put a message in the WhatsApp group and ask them to join. Ask them to join. Please put a message in the WhatsApp group with a link and ask them to join as soon as they can so that we can start our class. Definitely 15 people is not acceptable, right? We are 400 students in our WhatsApp group. Good morning, Basu. Good morning. Good morning. Perfect. I guess we can start our class. If you remember, in our one of the classes when we started our JavaScript, when we were discussing that particular live session, in which the title of the live session was Under the Hood, right? Do you remember that particular class, Under the Hood? In that particular class, we did a little bit discussion around JavaScript, and we understood JavaScript is synchronous, single-threaded, interpreted programming language. That is the definition we understood, and even we understood how that is executed in our JavaScript engine as well. We saw that particular thing in our browser as well, right? But if that is the definition of JavaScript, then what does this asynchronous JavaScript mean? And if there is a asynchronous JavaScript, then why do we say JavaScript is synchronous? That's something that is very interesting, and that's what we need to understand in today's class. First of all, what do we mean by synchronous? We mean synchronous that it is going to execute the line of code. It's going to execute second line of code only under one condition, when first line of code is executed. That's what synchronous means. But on the other hand, if I talk about asynchronous JavaScript also means that that's not going to happen. There are some coding lines over there that require more time than rest of the coding lines. So will we wait there? That's something that we need to understand. So this whole thing, how asynchronous JavaScript works, what is asynchronous JavaScript, and how that is executed in JavaScript engine as well, we need to understand at least that much in today's class. So let's not waste our time. Let's directly jump to our whiteboard and let's try to understand what we mean by asynchronous JavaScript. As I said, when we talk about JavaScript is synchronous no matter what. If anyone says you is JavaScript asynchronous, you will say no, it's not asynchronous, it's synchronous. Always synchronous. Good morning, Shubham. Always, no matter what. But let's, for our discussion for some time, let's try to understand what async is, and then I will tell you why it's called async JavaScript. And why do we say there is asynchronous JavaScript? I will come to that later on. But let's try to understand what do we mean by asynchronous JavaScript. Asynchronous JavaScript means that there are lines of code. Doesn't matter how many lines of code we have, but we have written 10, 20, 30 lines of code like this. Okay. If we talk about the previous definition that we have seen on synchronous JavaScript mean that this line of code will be executed only under one condition, when this will be executed, when this will be executed. Synchronous JavaScript means that if it takes 10 minutes of time to execute itself, it is not going to move forward and execute this. No, it is going to take 10 minutes, then only it's going to move forward. That's what synchronous means. But asynchronous mean that whenever there's a code that is going to take time, I will let it take time. But on the same time, I'm going to move forward and I'm going to execute rest of the code. That's what we mean by non-blocking nature. Even when we learn Node.js later on, we will say Node.js is non-blocking in nature. What do we mean by non-blocking? Non-blocking simply means, let's try to understand. Let's, for our discussion, understand there's nothing that is called asynchronous JavaScript. There's nothing. There's everything is synchronous. Okay, everything is synchronous for our discussion. If everything is synchronous, let's suppose over here I am trying to transfer a file on the internet, or I am trying to read a file using DOM. If it takes 10 minutes of time, don't you think synchronous says let it take 10 minutes of time and block rest of the execution? Do we understand that by synchronous, yes or no? Of course, that's what synchronous means. Which means if that would have been the case always, this would have been blocking in nature. That if this line of code takes 10 minutes, let it take 10 minutes. But on the other hand, we say Node.js is non-blocking in nature. What does that mean? That means if it takes 10 minutes of time, this should not block the rest of the execution. Rest of the execution should happen as it should be. So if it takes 10 minutes of time, let it take 10 minutes of time behind the screen, but let me execute rest of the code, and then at the end, I will execute that. That's what we mean by non-blocking nature. Let me come to asynchronous JavaScript a few seconds later. As of now, I'm going to create a file and I'm going to write some random JavaScript. So let me write index.js over here. And in this case, I'm simply going to write console.log, and console.log what? Console.log 1. Done. After that, I'm simply going to write console.log 2. Very good. And after that, I'm simply going to write console.log 3, and so on and so forth. I can write the rest of the code as well. I know that if I try to execute this particular code, it is going to give me the execution in proper top to bottom approach. 1, 2, 3. But let's add some function here. There's a function that I'm going to add. At this point of time, we will not talk about what that function is, but let me use some code over here. There's a function that we call as set timeout. Okay, it's a JavaScript function. Although it's not a JavaScript function, it's a browser function, web API function, but let's talk about that later on. There's a function, JavaScript function called as set timeout. What does this set timeout do? It receives two arguments. Number one is the function that you want it to execute. Let's suppose there's a function that is trying to print 3, and let me print 4 here. Second argument that it receives is after how many seconds you want it to execute. Let's suppose after 3 seconds, I want it to execute this. So basically what I'm trying to do over here is I'm simply trying to tell it, execute this line of code, execute this line of code, then execute this function. Of course, it's going to execute this function. I am telling it, please execute console.log 3 after 3 seconds. This 3000 is 3000 milliseconds, which is 3 seconds, and then execute 4. For our discussion, let's suppose JavaScript is purely synchronous. There's nothing that's called synchronous. What does that mean? That means it is going to execute this print one. It is going to execute this print two. As soon as it starts executing this, it will wait 3 seconds. It's not going to move forward and it will print three there. And then after 3 seconds, it's going to print four. That would have been the case when it would have been completely synchronous. Completely synchronous. But if I go here and if I try to execute the code, you can clearly see the output is 1, 2, 4, and then after 3 seconds it prints 3. Does it mean that right now the behavior that I'm trying to see over, that I'm looking at, it is actually non-blocking in nature, that it knows that this is going to take some time over there, which means it's not blocking rest of the execution. It allows the execution, then it executes this at the end. Do you understand what I'm trying to say? Yes or no? So this is non-blocking nature. But the point is, okay, sir, you made us understood what non-blocking nature of JavaScript means. But we still do not understand how it is executing this. Because we know JavaScript is synchronous in nature. Then how is it able to skip this execution first, then executes this, then comes to this later on? What is happening over here? That's what we need to understand in today's class. So our today's class will be completely dedicated to understand how code, whenever there's such thing that takes time inside our code, how that is executed. That's what we have to understand, right? Even let me give you one another very simple analogy over here. Okay, let's suppose over there, instead of 3 seconds, I don't have any time. I am telling it wait 0 seconds. After 0 seconds, please execute it. Tell me what will be the output in this case. Give me a quick output in the answer. Give me the quick answer in the output. Sorry, in the chat. Quickly. If the time is 0, according to you, what will be the answer? Good morning, Sukhjot. What will be the answer to this particular question? My time, see, this is what I mean. This is what I mean. Please execute this function over there after 0 seconds. So if this is the case, what will be the execution over here? So we say 1, 2, 4, 3, 1, 2, 3, 4, 1, 2, 4, 3, 1, 2, 3, 4, something like that. That's what we have. So there is a confusion. Sukhjot says 1, 2, 3, 4. Soumya says 1, 2, 3, 4. But if you try to see over here the execution, it is still 1, 4, 3, 2. 1, 2, 4, 3. Still over there, the same asynchronous output. Even if I go there, even if I remove this, even if I don't mention the second argument, I'm not even mentioning any argument of time over there. Even in this case as well, it is still 1, 2, 4, 3, which means right now JavaScript engine is actually treating this code in a different way. Do you understand what I'm trying to say? Actually, I have a problem in my left leg, so I'm not able to walk. Okay. So do you understand what I'm trying to say? So it means that whenever there's a code that deals with the time, that is asynchronous in nature, my JavaScript engine treats it a little bit differently. So what's happening over here? That's something that we need to understand. So for that, let's try to understand the discussion and let's go behind our let's go to the whiteboard and let's try to understand all of the code there. We know, do you remember, guys, all these 30 students, all these 25 students, not 30 students, 25, which is very unfortunate because today's class was one of the very important classes. I told you that it is important. I have a problem in my leg and still I am here teaching you, right? So that is the dedication that I'm giving, but unfortunately I'm not seeing people joining. So that's something that is not sahi. Ignore it. Let's come back. This is my code that I have. So first of all, the code that I have is console.log 1, like this. Then I have console.log 2. Then I have set timeout. I know what this function does. Set timeout is a function which receives two arguments. Number one is a function that it has to execute whatever it does. Let's suppose at this point of time, the statement that it's trying to execute is console.log 3, like this. Okay. And then we have after second, whatever the time is, it's irrelevant here. But we have console.log 4. This is my code that we have. Yes or no? Console.log 4. Now, do you guys remember the discussion that we did on our execution context? Do you guys remember that discussion that we did on execution context, call stack, how synchronous code is executed there? If you guys remember it, of course we did that. right? Of course we did. And we do remember that. We should remember that particular discussion, right? So let's try to understand the same discussion. Always remember that unless and until JavaScript do not put the code in the call stack, it will not execute it. Unless and until JavaScript does not put the code in the call stack, it's not going to execute the code. So we know that let my breakpoint be over here. At this point of time, the breakpoint is here, which means it's trying to execute this line of code. So I know at that point of time, my call stack will have a anonymous thread over there, and this is going to be executed. So by default, as soon as my JavaScript engine starts to execute this line of code, my console.log 1 will come over here. Yes or no? Yes or no? My console.log 1 will come over here. Of course, yes. And it sees that it's a normal code, so 1 will be printed over here, and this console.log, the console.log that I have, it has completed its execution. In a similar way, what it will do is it will now move towards the second line of code and put console.log 2 here like this, and it executes this code properly, prints the 2 in the output, which we have already seen in our under the hood classes that we have taken at least 2-3 weeks back. But after that, it comes up over here. Now, when it comes up over here, what it's going to do is it has removed the console.log2. At this point of time, it is simply going to take the whole set timeout code and it is going to put this code over there inside my call stack. So if anyone says that it is not going to put the code directly in the call stack, they are wrong. The call stack, the JavaScript engine will put the whole set timeout over here in the call stack, no matter what. It is going to put it there. Okay, but when this code set timeout or the code that deals with asynchronous type of code, when it is there, at that point of time, call stack will not execute it directly. Then what is going to happen, sir? Call stack will send this particular code to someplace else in the JavaScript engine. And what do we mean by that? Let me come back to that. Let's talk about something else. There is one very important concept inside our asynchronous code or inside our browsers or inside our JavaScript, which is called web APIs. Let's try to understand what we mean by web APIs. The most and important parameter that a JavaScript developer should keep in his mind, that we have to satisfy our browser. Yes or no? I told you that from day one that it's about browser. JavaScript deals with browser. Now, when we talk about the same browser over here, the same browser actually has lot of superpowers we can see. So the browser that we have, browser for us is a simple tool. Browser for us is a simple web, page displayer. It simply renders the web page and displays you that response. But that's not what it does only. But when we talk about browser gives you a lot of tools. Like browser gives you timers. For example, when we talk about the set timeout function, we write it as JavaScript, but it is not JavaScript. It is the browser superpower. What is it? It is browser superpower. So when we write set timeout, I'm not writing JavaScript. Remember that. That's why we say JavaScript is synchronous. So JavaScript will always remain synchronous when we are writing JavaScript. But if I'm writing set timeout, it's not JavaScript, it's a web API. It's a browser superpower. Do you understand what I'm trying to say? Do you understand what I'm trying to say? So set timeout function that I have written, it is not JavaScript, it's a web API because it's a function of browser. It's a function of browser. Browser actually has such kind of things in it. Similarly, what do we have? We have local storage in browser. We have local storage in browser. So if you want to access the local storage of browser, you can use proper functions. We have session storage over there. We have DOM. Come on, DOM. When we write DOM, again, it's not JavaScript. It's a web API that we are writing. Do you understand what I'm trying to say? So from past 2 weeks, when we started DOM, I was not writing JavaScript. It is a web API. It's a browser supermodel. Can you write DOM without browser? That's my question. Can you write DOM without browser? If you do not have browser, can you write DOM? No, we cannot. We have to write all things with respect to browser. We have to treat it with respect to browser only. Similarly, there is a fetch that we have. Fetching means that how we can fetch a data from an API, which we will understand later on. So there are lot of things, even console itself as well. When we talk about console, don't we know console is nothing but a part of a browser? When you go to inspect and see in developer tools, we see console. In a similar way, if I go to browser, let me go to browser over here. So if I go to browser over here, where is this browser? It should be here. So let me try to open any web page that we have. Even let me create my own web page. So I will simply go here and create index.html. And inside this, let me create this basic boilerplate. It will have an h1 tag, and that h1 will be adfer, right? So let me go live over here. So if I go live, adfer is here, perfectly fine. Let me go to inspect. Now, when we go to inspect, do you see console here? That's what we mean by browser superpower. Do you see over the app in applications? You see over the local storage. This is what we can access. You can see session storage. This is what we can access. Cookies over there. So the point that I'm trying to make you understand is that browser is not just for displaying a web page. No, it holds a lot of superpowers. That is why whenever we write asynchronous code over there, you have to understand you are not writing JavaScript, but you are actually using a web API from the browser. Am I clear? Am I clear? Yes or no? Do you understand what I'm trying to say? Do you understand what I'm trying to say? So let me go here and I'm simply going to say, give me window object. Now, when I try to open this window, what is this window, by the way? What is this window? Give me a quick confirmation. When we write window, when we try to access window, what does this window mean? Window actually means a simple that your web page that you have created, this window represents the whole tab. We know that, right? Let me try to expand this window. If I try to expand this window over there, let me drag a little bit down over there. Do you see NMNOPQRS? Let me go to S over there. Do you see set timeout function over here? The function that we used. So this set timeout function is a part of window. Yes or no? Do you see that? In a similar way, set interval over there. So when we talk about set timeout over there, as I said, it is not part of JavaScript, but it is part of window, and window is part of a browser. I hope that makes sense. In a similar way as well, the document object model, if I try to find over the document, you can clearly see document is here. Is the document JavaScript or Windows part? It's Windows part. So we can simply go over on fetch as well, which we will see later on. Fetch. So what is this fetch? This fetch is nothing but the Windows superpower. So we can clearly create a picture over here, picture of one thing, which is that when we talk about our JavaScript, JavaScript is a simple, normal language that we have. On the other hand, we have our browser. Very good. Now, this browser over there has a lot of superpowers. Superpowers, as of now, we have seen only one, which is timer. Later on, we will see rest of the superpowers. But whatever those superpowers are, now JavaScript requires them because there's a requirement of it. When we talk about DOM, there's a requirement of DOM. When we talk about timers, there's a requirement of timers. When we talk about fetching a data from the API, there's a requirement of it. So somehow this browser has to talk with JavaScript. Do you understand what I'm trying to say? Unless and until browser do not talk with JavaScript, how can you use such kind of functionalities? And browser loaners, you can say browser loaners or JavaScript borrowers, these all superpowers via object, and that object is called window. What is that object called? Window. So window is the object that actually loans all of the superpowers to the JavaScript that we have. JavaScript engine that we have via Node.js or via the browser itself doesn't matter, but yes, it loans all those superpowers that we have. I hope this makes sense. So, guys, you tell me, and you have to write yes or no. All the 30 students, all the 28 students, you tell me quickly in the chat. When we talk about writing our code like this set timeout, am I writing JavaScript or am I writing something that belongs to window object? Quickly give me an answer. Am I writing JavaScript or am I writing something that belongs to the window object? Give me a quick confirmation. I am writing very good. Something that belongs to window object. And whatever belongs to window object at this point of time, you have to understand that they are called web APIs. What are APIs? We will come to that later on, but right now, just give them a title. That whatever you see over there, whatever you see, even local storage, we will use it later on. We will use, set timeout, fetch. We will use document. We already have used. We will use set interval. We use a lot of web APIs. So lot of web APIs over here we will see. So that's what we need to understand, that when we write set timeout, I am not writing JavaScript. That's why the definition JavaScript is a synchronous language still holds. It's always JavaScript is synchronous. But when I include such kind of things, is this JavaScript? It's not JavaScript. Now there's a external tool, window.setTimeout. These are web APIs that we have. So you need to understand, when I say that I am writing JavaScript, if it's a pure JavaScript, then it is synchronous, no matter what. But as soon as I start writing such kind of set timeout, as soon as I start writing clear timeout, set timeout, fetch, as soon as I start writing local storage, session storage, all those things, you need to understand I am using window dot something. They all belong to an object called as window. Am I clear? Perfect. Give me a quick confirmation in the chat. Quick confirmation in the chat. Sir, yes, sir, we understood. Now, if we understood that, let's go here. Let's understand the same analogy and let's try to understand now what happens over here. It means now when I have to execute my code, there's one another thing that got introduced. Number one is called call stack. Number two section, there's one another part inside my JavaScript engine which is called web APIs. So there's one another particular part that is right now included called as web APIs. So there's one another part that came into picture which we did not discuss in synchronous JavaScript, but now it is in picture, which is called web APIs. And we already have the console and all those things. Let's not talk about that, but let's talk about this. Now see what happens. I have the code. Remember the code that I have? So this is my code that I have in my VS Code. So let me try to open this and let me try to cut it out. So this is the code that I have. So let me try to add to the current page. Okay. So where is it added? It is added here. So let me add it over here quickly. Perfect. So this is the code that we have, right? So how my JavaScript engine is going to execute it now, since I know that this particular code, it belongs to the web API section. So what's going to happen? We know that it is synchronous. JavaScript is synchronous. So it will try to execute from top to bottom approach. So it will execute this line of code. It will put console.log one in the call stack, because we know unless and until it's not in the call stack, it's not going to execute. And remember, write this statement in your rough copy. If you want any code to be executed, it must be in call stack. Unless and until it's not in the call stack, it's not going to execute, no matter what. Whether it's synchronous, asynchronous, whether it is window object part, whether it's normal JavaScript, doesn't matter. It has to be in call stack. So now when it is in the console.log, can my console.log contain any other thread? No, it's a single threaded. So it's going to execute this print one in the console. Let's suppose this particular part of my JavaScript engine is console. Done. Then it will move to the second line, console.log 2. As soon as it sees this, it executes it. 2 is printed in the console. Now it has executed this. My call stack has only anonymous thread now. After that, my JavaScript engine is top to bottom. So it is going to take this whole set time out. So it will take this whole set time out function. Okay. And it is going to take this set timeout function like this, like this, like this. And whatever it is going to console.log 3, it is going to place it inside my call stack. Let's suppose the time I have not mentioned here, but let's suppose time is 3 seconds for my discussion. Okay. Now, when my call stack sees this particular code, now if call stack is intelligent enough, it knows that this is not pure JavaScript, but it is a web API. Right? It knows it because it's a window.setTimeout. It knows what setTimeout means. So as soon as it enters in the call stack, and remember one point, that even if it is synchronous or even if it is web API, it will enter in the call stack. Usually people say as soon as we see that it's a asynchronous code, it goes to some other part of JavaScript engine. No, it enters into the call stack first. And call stack determines whether it is web API or not. If it is not a web API, it's going to execute it directly. But now call stack sees that, okay, this code is not normal code. It's a web API code. It is a superpower of browser that has been loaned to the JavaScript via object called as window. So what it is going to do, it's simply going to send this set timeout over here. What's it going to do? It is going to simply send this set timeout over here, and it is going to be erased from here. Now, when it is being sent from my call stack, I will show you this as well, how it's executing its code. There's a software online website which we use, from which you can get a complete idea of how it executes the asynchronous code or web API code, whether it is DOM, whether it's set timeout, or any other code. We will talk about that later on. We will see that later on in our second half of today's class, but pay attention. Now, it sees that it's a web API. So over here, it actually sends this code to the web API. Now see, now it has sent this to web API. So what it will do is it will simply start putting console.log 4 over here. But tell me one thing, has it executed set timeout right now? No, it has not. Why? Because it has sent this, it has determined that it is a web API code, so it is going to send it to the web API section of my browser. But on the other hand, it will take the rest of the synchronous code, put it in the call stack. But on the same time, remember this, on the same time, it is going to start the timer over here. So 3-second timer is going to be started immediately. It is not like that it is going to first wait for the execution of this code, then start the timer. No, since the time is 3 seconds over there for this, 3 seconds, so it's not going to wait that it is going to execute this and then start the timer. No, but as soon as it pastes this code in the call stack, it has in the behind, in the web API's part of my browser or the JavaScript engine, it has already started the execution of the timer of the 3 seconds. Okay, now meanwhile this time is going on, it will execute this, it's going to print 4 here. Now my call stack is empty because now it sees there's no code that needs to be executed. Am I clear until now? Give me a quick confirmation in the chat. Am I clear? Perfect. Moving forward. Now it has printed 4 over here, and we know behind the screens my timer in the web API's part is still going, and it is going to take 3 seconds of time no matter what. And let's suppose it has completed the 3 seconds. Now what will happen after that? According to our code, it has to execute this function after 3 seconds. That's what it is supposed to do. But after 3 seconds, does it mean it is going to send this function directly over here? No, there's one another part inside our JavaScript engine, and that is called callback queue. What is it called? Callback queue. So as this callback queue is there, so that all the callbacks that are going to execute their complete their time inside the web API section of JavaScript engine will be sent to callback queue one by one, so that later on from the callback queue they will be sent to call stack for execution. So what's going to happen over here? As soon as this 3 seconds time is completed, we know there's a callback function that is associated with it. So whatever that callback function that is associated with this timer, as soon as timer is completed, the callback function will be sent to my callback queue. The callback function, it is not going to be directly sent to call stack for the execution, but it will be sent to the callback queue. So if anyone asks us, hey, what is callback queue? Callback queue is nothing but it holds all the callbacks that are web APIs that are asynchronous in nature in its queue in a line based on their order, based on their execution order or the timer order that we have. Okay, now as soon as this callback is sent over here, now over here we don't have anything because its timer is ended. Callback is sent to the callback queue. Now after that, I know in order to execute this callback, we must send it to call stack. But will it be directly sent over here? No. There's one another component inside JavaScript engine that we have, and it is called event loop. Now this is also asked in interviews. What is event loop? What is callback queue? Okay, so what does this event loop do? What does this event loop actually do? This event loop has only one agenda over there, which is that it is going to continuously monitor my call stack, continuously monitor my call stack and callback queue. And before I talk about what event loop does, tell me one thing. Let's suppose for our discussion, listen to my question clearly. Let's suppose my timer is going on and it has completed the code. And let's suppose there's a lot of code over here in the JavaScript engine. So as soon as it has completed the timer, it will send the callback here, right? And then over there, there's still some code that is being executed. Whatever the code is, there's still some code. Will this callback ever reach the call stack until there's a code that is still being executed? Yes or no? If there's some code in the call stack, will it ever receive anything else after that? No, it's not going to receive. Because we know our fundamentals. Our fundamentals are clear that in a call stack, at one point, there's going to be one thread only. We know that. That concept is pretty much clear. So this calls event loop that we know for this example, my call stack is empty. So what does this event loop do? Event loop's work is only one thing, which is to continuously monitor my call stack continuously. And as soon as it sees that this call stack is empty, now call stack does not hold anything, it sends a message to the callback queue over there. It sends the message to the part of the engine that is known as callback queue, and it talks to it, says, hey, do you have anything there that you want to execute? If you want, call stack is empty, send it. So what is this event loop? It continuously monitors my call stack, and it sees if there is anything inside my call stack, then it's going to stay idle. But if there's nothing in the call stack is empty, which means if I want to execute anything, I can send it there. So it sends a message to the callback queue and asks it, hey, if you want to send something, send it. Right now, call stack is empty. And then callback via this event loop is going to send its callback here, and then it will print 3 over here in the console, and now my callback is empty. This is how asynchronous code executes its code. Now I understand that, sir, no, there's still an ambiguity. We have not understood entirely. For that, let's take one more example over here to understand the same discussion. What I will do is I will simply go and give it a time. Let's suppose the time that I'm going to give is 3 seconds. Perfectly fine. After that, I'm simply going to go give it set timeout over there. Inside there, I'm going to give it a function, and that function will have, let's suppose, time, and that time is going to be console.log 5, and it is going to have time over there as 1 second only. Done. And finally, I will have console.log 6. Understand this example. So this is console.log 1, console.log 2, after 3 seconds, print 3, console.log 4, directly console.log 5 in a set timeout, and then console.log 6. If I try to execute it, you can clearly see 1, 2, 4, 6, 1, 2, 4, 6, then 5, because it is a smaller timer. Then after this, this is being executed. We know that, right? From the code execution. But let's understand it with respect to my call stack, with respect to my JavaScript engine. So I'm simply going to cut this code and let me add to a new page. And this is what we have. Let's understand again. I know in my JavaScript engine, there are 4 parts that we have right now. So number 1 is called call stack. Number 2 that we have is called web APIs. Web APIs part. Done. And then third one over there is called callback queue. Callback queue. And fourth over there is called event loop. I know these are there. These parts we have inside our JavaScript engine. We have discussed that. We have understood that these parts. Now let's start the execution. Okay. Let's try to understand how it is going to execute this code that we have. Simply. Okay. I know that this is a normal code, so it will be placed inside my call stack. So console.log 1. And as soon as it sees that it's a normal code inside my console, inside my output, it is simply going to print what? It's simply going to print 1. Then it will move to the next line of code. This is execute. It will move this and send it to call stack. So now we will have console.log 2. And as soon as it sees it's a normal code, it will print 2 in the console. Done. After that, this console will be removed from my call stack. We will not have such thing over here. Then finally, what's going to happen? It's simply going to execute this, and it's going to take this whole set time out. So this whole set time out function will be with its all code that it has, with its timer. It is going to be taken and placed inside my call stack. So console.log 3 will be placed over here with its timer that we have. Now, as soon as it's placed in the call stack, JavaScript engine will come to know that it's not normal JavaScript, it's a web API. And from here, it will be sent to web APIs. Now, if you guys tell me, as soon as it's sent here, will its timer start immediately, or will it wait for rest of the code to execute first? When will its timer start? Immediately or after all the code execution? Quickly tell me. Quickly tell me. That will the timer start immediately or after the whole code executed? The timer is going to start immediately. So timer has started, timer has started, timer has started over there. And let me write this timer is for callback 1 or timer 1. Let's say timer 1. Done. Now after that, what it's going to do, it's simply going to remove this whole code, because now it is being sent to the callback and its timer has started, and it will bring console.log 4 here, right? And then it's going to print 4 here. Then again, it's going to take the whole set time out, this one, and place it with the timer. Place it with the timer. But you guys tell me, when this is placed, it is quite obvious and evident that timer 1 might have executed some time, right? Because वो timer तो पीछे से चल रहा है, so there's a possibility that it might have reached to some time already. So when this code is being added in the call stack, now it will be sent to the this web API's part, and over here we will have timer 2's time starting, right? Timer 2 is time starting, and this will be removed from here, right? This will be removed from here. Now there's a possibility when timer 2 was added over here, at that point of time, half second of this timer is already done. Something that is a possibility as well. And finally, console.log 6 will be here, and 6 will be printed in the console. Now you guys tell me, among this timer 1 and timer 2, which time will end first? Which time will end first? This is running on the same time, this is running on the same time. Timer 2 or timer 1? Timer 2 or timer 1? Which is going to be added, completed first? Of course, it does not matter. Even though this timer started first, but this time was much more larger than timer 1, timer 2, and it's 1 second. So when this is going to complete its timing, at that point of time, my timer 1 might reach here. Now this timer has completed its code and it will be sent over here. So timer 2's callback function. So callback function 2 will be sent to callback queue, and this timer will be removed from my web API. Yes or no? Now timer 1 is automatically executing its code still, but on the same time, it will check whether call stack is empty or not. So what about 1200 timer for 1200? What does that mean, 1200? You want me to put 1.2 seconds there? We will do that as well. Let's understand this example. Then after that, I will do that. Okay. Now, the callback 2 will be sent in the callback queue. Now, after that, I know the timer is still going, but my call stack is now empty. There is a possibility the call stack is empty because rest of the code is executed. Now, event loop will come into picture. Event loop is continuously monitoring call stack. And what it will do, it will send a message to callback queue and then call stack. Hey, call stack, if you are empty, I have a callback function in the callback queue. Let me send it there. In the meantime, there's a possibility that this timer might end itself or it is still going depending on the time, right? So now callback 2 will be placed over here, and maybe there's a possibility in the meantime callback 1 will be placed here. Now what it's going to do, it's going to execute this. It will print 5 in the console. When it prints 5 in the console, this is executed. In the meantime, this timer, if it has ended, callback 1 will be placed here. Similarly, event loop will be responsible for sending the callback 1 now over here, and after that it is going to execute and print 3 in the console. That's how we see 1, 2, 6, 5, 3 here. I will talk about it, why timer 2 first. But before that, rest of the people, do we understand? For Sadi, I'm going to explain why timer 2 first. Am I clear for rest of the people? I hope. Let's repeat it for Sadi. For Sadi and everyone else who is facing any confusion. Sadi, let's understand one thing. This code is executed, 1 is printed in the console. This code is executed, 2 is printed. Now, this set timeout will be placed in the call stack, and it knows it's a web API. Its timer will be started here, right? Yes or no? Sure. I will tell that, Basu. I have an issue with my legs, so sometimes I might do these things. Okay, let's pay attention here. Let's pay attention here. Tell me, Sadi, especially you, when this set timeout is being executed, what is the time it holds? 3 seconds. So it is going to simply start the 3 second timer over here. Yes or no? Yes or no? Done. After that, the timer is going on and it will be very fast. It is executed. Now let's suppose when this is executed, it will print four, what is called 4 here. It is going to print 4 here. Then it will take and execute this, and its timer is being sent. Now when this timer started, this is 1 second. At that point of time, there's a possibility that this might has completed half second. Half second it might has completed. So how much time is remaining there? When this timer was added in the web API, let's suppose this has completed 0.5 second. Now, what is remaining for timer 1? When this timer was added, what is remaining? Tell me quickly, Sardi, especially you. When this timer is added in the web API, timer related to set timeout 2, at that point of time, this timer was already going. Let's suppose at that point of time, it has already completed 0.5. So what is remaining? 3 minus 0.5, 2.5 second. Yes or no? So it means when timer 2 was added, timer 1's 2.5 seconds for our suggestion, for our discussion, we have supposed it is still remaining. Now tell me, is 1 second greater or 2.5 second greater? Is 1 second greater or 2.5? Of course, 2.5. So which timer will complete first? So when this 1 second is completed, this is also going to complete 1 second. But don't you think 1.5 second is still remaining? That's why timer 2 will be sent first to callback queue. The callback function 2, the callback function that's associated with timer 2 will be sent to the callback queue. Am I clear now? Am I clear now? Done? Done? Perfect. Moving forward. Now, let's not waste our time. Let's not waste our time with all these theory. What's a web API? I think you have joined late. We have already understood what web APIs are, right? But let's repeat quickly. Whenever we open our web page, at that point of time, we know there's a window object that is associated with it. Go with, right? The web page that we open, the tab that is being created, that's what we mean by window object, right? So if I try to open window object, this window object has lot of superpowers within it. Whether we talk about cookie store, whether we talk about document object model itself, whether we talk about fetch, which we will see later on, or whether we talk about set timeout, set interval. So you can clearly see over there that there's a function called as set timeout, set interval. Now, these all superpowers of browser, they are superpowers with help of which you can do a lot of things. Now, JavaScript does not own them. JavaScript does not know what set timeout is. But browser window object knows what set timeout is. JavaScript does not know what fetch is, but window knows what fetch is. So the JavaScript engine that we have, over here, let me go to previous page. So this JavaScript and the browser with it is superpower. Browser loans all those superpowers to JavaScript via object called as window. Now, these all superpowers are called nothing but web APIs, like timers, like local storage, session storage, or cookie storage, or fetch, or set timeout, set interval, all those things that we have seen in the window. So all those are called superpowers. And they are not JavaScript. They are part of window object. And that's how my JavaScript loans them. These are called web APIs. Now, someone asked, sir, are they part of browser or JavaScript engine? They are part of browser. But we know that the JavaScript engine Node.js that we have, the Node.js engine that we have, it is Chrome's V8 engine, which means whatever engine we have inside Google Chrome, that is the same engine which we have in Node.js. That's why even without window object as well, we can access them inside our JavaScript. Do you think I have written window.setTimeout? No, but they are part of JavaScript engine. Okay, I hope that makes sense. Perfect. Window is everywhere, but see, now over here we don't have window. Why? Because they are directly placed there. But if we talk about our web page, over here we have window properly. Done? Perfect. Moving forward, we will talk about that. Basu, allow me a second. Let's first of all understand all the things. Then whatever time you will put, you will automatically understand that. There's a website that I'm going to use. Let's hope we have that website. Allow me a second. Let me find that website. Okay. It is part of JavaScript browser actually. It's part of browser. But since we have the same everything embedded in the JavaScript engine, we are using the same engine, so it's part of everywhere. So allow me a second. Let me find that particular website and then we can actually discuss it. Okay, give me a second. So set time out code. Can we write in browser? Please write one time. Over there it will work as well. Guys, let's wait some time. Okay, everything will be done. First of all, our intention is to understand how it is being executed. Then we will come to all that, how to fetch APIs, how to do all of that thing. Let me paste a URL over here. I will share it in my WhatsApp group later on as well. In our WhatsApp group, this particular URL called as latentflip.com, and let's hope it works. There's a possibility it might not work, but let's hope it works. It's a website. You have to ignore it, what it is. Okay, whatever it is, even I don't know, but it gives you a complete picture of how JavaScript code executes its code. It gives you complete picture of it. At this point of time, let me simply copy all of the code that we have. So this is the code that we have, Control C, and let me simply paste it inside our browser. So I will simply go here and paste this code. So we have console.log1. Let me try to zoom our browser a little bit. So we have this website. We don't know what this website is, but we all can agree to one point, that when I try to show you how it executes its code, I showed you that we have four parts: call stack, web APIs, callback queue, and event loop. We have those four parts. If you look at this particular website, call stack, web APIs, callback queue, and event loop, same four parts. So if I try to execute this code, it's going to show you how exactly this code will be executed in JavaScript engine. That's what this website does, nothing else. Okay, now pay attention. We have console.log1, console.log2, set timeout 3 seconds, console.log4, set timeout 1 second, and console.log5. I will share it in my WhatsApp group later on, okay? Adil, let's try to run it. So if I run it, see, I'm going to shut my mouth. Let's try to rerun it, because there's some what is this called, some bug here. It's printing console.log here, keeping it always, but that's not the issue. That's not what it should do. Okay, let's try to run it again. Okay, so there's some issue with this set time. Let's try to refresh our page. Okay, it has placed this console.log1 unfortunately there, but let's try to refresh this page and understand how it executes its code. Okay, so I have the same code here. Let me try to run it. Perfect, it works now. Great. Okay, see, let me execute it and let me pause it after every line of code so that you can understand how it executes its code. Okay, I will try to rerun it, but let me pause it. So when my executor is on console.log1, my call stack holds a particular function called as console.log1, and it's going to execute it. Done. That's what we have seen as well. I want you to be continuously be active in the chat with yes or no's. So first of all, it will take this console.log1 and place it inside this call stack and execute it. Let me try to resume it and let me pause it. Now, second thing that it's going to do is it's going to place this console.log2 in the call stack. Now, when it places the call stack, it sees it's a normal code, it executes it, done in the output. Let me resume it. Now, when I resume it, it will take the set timeout code and place it in call stack. Now, from our theoretical discussion that we have discussed, I know from call stack where it is going to go. Where? To the web API section. And let's see that. So when it goes over there, you can clearly see as soon as set timeout was placed in the web API, its timer starts immediately. Yes or no? Do you see that? Its timer starts immediately over here. Quickly. So it does not matter that it is going to wait for first of all rest of the code to be executed. No, but it starts the timer immediately. In the meantime, it's going to take console.log4 and place it in the call stack, execute it. Then I will resume it. So let me resume it. Now set timeout is placed there, but you can clearly see one thing. That once my set timeout was placed inside call stack, timer 1 was running. It was not waiting for this timer. It was continuously running, even though they have minimalized the time over here, so you won't be able to properly visualize it. But for our proper visualization, let me try to make it much more time so that we can properly visualize this. Okay, let's understand. This yellow over here is event loop. This yellow over is event loop. and let me make it much more greater than, let me make it 3 seconds. Now let's pay. And let me remove one of the console.log because there's no point of it. Okay. So let me go here. Now see, let me try to pause it. Console.log one is there. It is placed over here. See how it's executing its code. Properly, everything is working. Everything is working in callback queue. Now that callback function will be sent. It will be executed and done. Now let's see the same thing slowly. I will rerun my code. Let's refresh the page. Let's rerun the code. Save and run. Let me pause. The first thing that is going to happen is it's going to place the console.log one in the call stack and it's going to execute it, send one to the console. Done. Let me resume it. Let me pause it. Second thing that it's going to do is it's going to place the set timeout in the call stack. That's why I said you need to understand that all the web APIs will be sent to the call stack first and then they will be sent to the web APIs section. Let me try to resume it and then pause. Now see, as soon as it is sent to web APIs, you can clearly see timer immediately starts. So it does not wait for all the code to be executed, but the timer starts immediately. Yes or no? I hope that makes sense. Let me pause. Now, when I resume it, let me pause it again. Now, console.log4 will be sent to call stack. And it's a normal code, it will be executed. Then I will resume this. Now we have another timer over here, which is this. Now we can clearly see it is sent to call stack, and after that it will be sent to my web API section, and its timer immediately starts and keeps executing. The callback will be sent over here, and then one by one callback via event loop will be sent over here. I hope that makes sense. I hope we have completely understood how the JavaScript asynchronous code executes itself. Do you want me to show this once again? Do you want me to show this once again? I will show you, once again as well if there is a requirement of it. If not, we have understood how asynchronous code is executed. Am I clear? Done? Or once again? Quickly tell me. Once again? Perfectly understood? Tell me guys one thing here. If we understood, sir, if the web API knows set timeout part of browser, then why they are showing anonymous in web pages? Because if you remember that the functions that do not have name with them, they are called a function that does not have a name assigned to it. Such type of functions are called anonymous functions. So they are placing anonymous functions here. Remember that. What is that function called that does not have a name associated with it? Called as anonymous function. Now tell me one thing. Did you saw two timers at the same time? Maybe I did not, because I think there's a bug inside this website right now. Not sure what's happening, but there should be two timers at the same time in web API. Let's try to run it again. So let me save it, run. Done. Perfectly fine. Very good. Send there. Timer is starting. Done. There. Timer is perfect. You can see two timers at the same time. Now timer 2 is ended first because it's 3 seconds. Then it is sent via event loop. And see, this comes into picture. It runs over there when call stack is empty. That's how all asynchronous code is executed. I hope this makes complete sense. I hope we have completely understood what is happening over there. So I was not able to write set timeout function console. We will see that in 2 seconds. Okay, give me a second. Am I clear? Done? Am I clear? Perfect. Let's go over here. Let me try to create a new tab in which I will place the same, not this code, sorry, but let me copy the same website here. Allow me a second. Let me copy the same website link. I will share it with all of you as well. So allow me a second. Control C. Let me close this. And let's go here. And let's understand how DOM is executed in browser. Okay. So why is it not giving me the DOM code? Let me close this. Let me go here, paste this, and there's some issues with the loopy. Okay. I'm not sure what the issues are, but there are some issues with it. So there is supposed to be click me option. So let me run it. There are some issues with this. So let me see if I can find the another website. I will talk about that. Go with. Allow me a second. Okay, I will talk about that. Allow me a second, because there are some issues with this website. It's a very old website. Remember that. It's a very old website. When we say it's a very old website, I mean it is, I guess, 2015. 2015 में ये वीडियो इसने बनाया था. Basically, if I try to copy the link, let me place it here. You can clearly see as soon as I go to this website, there is this YouTube video. If if you ask me where have you learned all these things, this is the person which have made me understood what event loop is. This is the person who has made me understood what event loop is. So watch this YouTube video. Watch this YouTube video. And it will give you a complete understanding, which I have said. It is going to tell you the same thing as well. So watch this video later on. Govind, as I said, I will do that as well in the tab console. Allow me some time. So let's close this and let's understand one thing. You can see now there is a different code right now in this particular editor. Let's understand what this code is actually about. Okay. You can see I have this button which says click me. And there is this code. It is an older way of how we used to write the things here. It says that on the button, there's a button that you have which is click me. On that, please add a click event, and whenever that click event is executed, execute this function which will say you click the button after every 2 seconds. Then we have console.log hi, then normal set timeout function, then console.log welcome to loopy. Try to understand this code. This first line of code simply says on my document there is a button element on which please add a click event, and whenever that click event is executed, click is performed. At that point of time, execute this function. Then console.log hi, set timeout, and this. Now see how those events are executed in web APIs. We know that even document dot add event listener, element dot add event listener, all those things are also web APIs. So now if I try to save and run, normally this is executed. I know this whole code belongs to web APIs. It is placed there. After the timer executes its code, and it will be sent to the callback queue. Event loop comes into picture. Now it is sent here. It executes it. But don't you see web API still contains something? Don't you see web API still contains something? Yes or no? Of course, there is something still. And this is how DOM actually is executed. Because when we talk about events, events are registered always. For example, on an H1 tag, on an P tag, on a button tag, I have added a click event. Now, what does that mean? That means when the user on the web page, that element is waiting for the user to perform the click. Simple. In a similar way, if you see web APIs, although my call stack is empty, which means you need to understand when you write your events and all those things on your web page, you might think all the JavaScript is not executed, but every JavaScript is executed. But there is all the events and all those things, they are placed in web APIs. Right now my callback queue is empty, right now my call stack is empty, but they are in web APIs. Now, how is this code going to be executed? I know when I click on this, this will start its timer. See, let me click. I click, timer started over there. This will be sent from here. Timer starts again here. Then it is sent over here. That's how events work. When I click on it, the function that's associated with it, it will be sent to call stack. From call stack, it will be sent to web APIs back. Start the timer, sent to callback queue, and again working. It means if I start clicking continuously over here, you can clearly see how many callback queues are right now in a proper queue because I have clicked that many times. So now one by one, all those click events will be performed from callback queue to call stack to web APIs. Timer starts to callback queue to call stack to web APIs, callback queue, call stack, web APIs via a particular component of my Node.js called as event loop. This is something very interesting. That when we talk about events, this is how they are actually executed as well. So I know events are such kind of code in my web page that wait for your action. Unless or until you do not perform an action, they will not execute themselves. But as soon as you perform the action, what's going to happen? Their code will be sent to the call stack. From call stack, they will send the timer, start the timer, and then execute if there's a timer involved. If not, then directly they will be sent to the callback queue and call stack, and they will execute the code. Right now, timer is involved. That's why timer is starting. But if there's no timer involved, if it is directly executing a particular function, then we will not have timers. Timers are there when there are timers involved. With this, I think we have gotten a complete understanding of how asynchronous code is executed, how JavaScript takes web APIs and how web APIs are taken care of. Another very important example. Remember when I actually went to my VS Code and I actually removed the time over here, I made it 0. Remember, at that point of time, you guys gave me a wrong guess. You told me, sir, since time is 0, the output should be 1, 2, 3, then 6. 1, 2, 3. Let me make it 4. This is what you said. That, sir, output should be 1, 2, 3, 4 because there's no time involved. So if there's no time involved, why is it descending 3 to the back? Because it is quite obvious. What is quite obvious? That we need to understand there is a call stack, there is a web API, there is a callback queue. In between, there is an event loop. Now, this code is sent here, 1 will be executed. This is code is sent here, 2 is executed. Then this code is executed here. Now, this set timeout will be placed in call stack. Now, when this set timeout first time placed in call stack, do you think it worries about what the time is? Do you think it worries about what the time is? No. It sees it's a web API, irrespective of what the time is, it will send it to the web API's part. And then over here, it starts the timer if there's any. And by default, my timer, if you do not mention the time, it still takes 1 millisecond. That's by default. Note that down. And that was asked to me in one of the interviews. That if for a set time out, there's no time that I have mentioned. So what is the default time? It's 1 millisecond default time. Although some people say 0.66, but it is 1 milliseconds. Okay. So this time is irrelevant because when we talk about executing this code, it is not actually executing set timeout, but it is actually about executing the callback function. And when will be this callback function executed? When its timer is ended, which is by default 1 millisecond. So 1 millisecond timer is ended, then it will be sent to callback, then via event loop to call stack if call stack is empty. If call stack is not empty, it will never be sent to call stack. It will wait. It has to wait there. Doesn't matter how much time has gone. Let's suppose, let me give you a simple scenario here and you will answer me. Let me give you a simple scenario here so that I can understand whether you have understood all those things or not. Let's suppose I have a lot of other code. There's a lot of other code and all of this is synchronous. There's no asynchronous code. There's only one asynchronous code, which is this particular function called as set timeout, nothing else. And how much time it has? How much time? It has 0 seconds. For our discussion, for our example, let me make it 1 second. Okay, for our discussion. You guys tell me now. When this code is sent to call stack, it will be sent here. When it will complete its 1 second, from here, it will be sent to callback queue. Now, for my purpose, the requirement that I had, I wanted this call console.log 3 to execute after 1 second. Let's suppose this coding lines, all the synchronous code line, they take 20 seconds. Now tell me, will this be executed after 1 second or 20 seconds? Quickly, will this code be executed after 1 second or 20 seconds now? Even though time is mentioned as 1 second. When will this code be executed? I can see few answers. Very good. After 20 seconds. After 20 seconds. So you need to know code from callback queue that we have. It will be sent to call stack only when event loop tells it. When event loop tells it that now call stack is empty. Unless and until call stack is not empty, it's not going to send the callback queue there. I hope that makes sense. So every synchronous code, irrespective of whether it has time with it or not, it will be executed after all synchronous code is executed according to their order inside callback queue. Whatever the order we have. Okay. I hope that makes sense. With this, we will take a break of 10 minutes. Okay. And after 10 minutes, we are going to discuss some other topics of asynchronous code, and we will try to understand some very important topic called as promises. Sir, who runs web API? It's JavaScript engine, right? JavaScript engine. No, it's not multi-threading. It's single threading always. Although there are multiple threads that we have in Node.js engine, but it's always single thread. There's a thread. Single threaded, right? Single thread. At one point, it's single threaded. Perfect. Great. So after this, we are going to discuss one very important. We are going to have one very important discussion after this called promises. Now, promises is also a topic which is asked in 100% interviews, like 100%. So that's why you need to understand why it's very important. So do not leave the class. Stay here even in the break as well. I will share this link later on in our WhatsApp group. Do not leave the class in the break. Stay here. Let me see how serious you are. Be here. And I will definitely, sir, please send the WhatsApp group link. Soumya, you are not in our WhatsApp group. Why is that? So let me share. Please remind me at the end. Okay, Soumya? Please remind me at the end. I will definitely. Okay, let me share it in the break. Okay, let me share it in the break. So, guys, see you exactly after 9:50 seconds. Okay, thank you, guys. Bye, everyone. Do not leave the class. Stay here. We have to discuss promises, but after the break. Okay, see you. Bye. Hey guys, hi everyone, welcome back. Hello everyone. I hope I'm audible as well as visible. Am I? Hello guys, hi everyone. I think I should be visible, right? Perfect, great. Soumya, I have already shared the WhatsApp link in the chat. I hope that you have already joined, right? And please share with your friends if you have any who want to join. So please do that, okay? Or anyone else as well. So you can ask them to join. Okay. So I guess we can start our class. So I think we have properly understood one of the very important discussions related to our JavaScript when we involve web APIs in it, and we have understood how asynchronous code is executed, right? Now let's understand one very important point. We have already seen set timeout. Do we have anything else? Yes, we have anything else in it as well. With respect to timers, you might see two functions. Number one is called set timeout. Now, when we talk about set timeout, it has two arguments. Number one is the function that you want to execute, which means a callback function, right? Like this. And second thing is a delay in milliseconds. So, what you want to execute after this amount of time. So, this is what we mean by set timeout. Now, what does set timeout actually mean? It means execute this particular function only once. It means it is going to console this adfer over there only once after 2 seconds. That's it, nothing else. So after 2 seconds, it's going to print adfer. But on the same time, sometimes you might want to execute something after some interval of time for infinite amount of time. In that particular case, you can clearly go over there and use one another type of function called a set interval. Now, what does set interval mean? Set interval means again the same syntax, a callback function, and then a particular delay, whatever that delay is. But whatever function does, whatever you ask it to do, it is going to simply execute that for infinite amount of time. So if I execute, you can clearly see after every 200 milliseconds. So let me create 2 seconds here, and let me remove this and let me stop this and execute it. If I now execute, you can clearly see after every 2 seconds answer will be printed. So this is after intervals. So it will be executed until you stop it. You make it stop. So that's what we mean by set interval. Now, if I remember correctly, someone was asking that, sir, I'm not able to execute set interval in or set timeout in a browser, right? So let's try to execute that. So let me simply go here, refresh the page, and let's open our web page here so that we can actually execute set timeout in our browser. Remember, in our classes, I told you that whenever you learn any method, always remember two things. Number one is what it does. That's not the only thing that you have to learn. Number two is what it returns. Always talk about two things. If anyone asks you, if anyone teaches you any method, ask him what it returns. Ask him what it does. Usually, every single person talks about what it does, not what it returns. Now, what it returns is very important thing. Let me go here. Let me talk about this set timeout. So let me go, let me write set timeout. So let me simply go write set timeout over here. I know it receives a function as an argument. So let me pass a function like this. And let's suppose it simply goes and does. What does it do? It simply consoles adfer over here like this after every 2 seconds. So console.log, let me close the function, and after that it does it 2 seconds. Done. Perfectly fine. And if I execute it, you will see two things. You will see two things. Number one is what it returns, which is two, something two. We don't know what this two is. And then adfer. Adfer is what it has to execute after 2 seconds. If I try to again execute it, you can clearly see now it says three, which is, and after that it executes adfer. Now, if I execute again, it says four and then 200. But what does it return? We all can agree to one point whether when we talk about set timeout, it returns a numerical number. Even if I go here, if I talk about this set interval as well, set interval, and click enter, you can clearly see it returns again a numerical number and starts printing adfer after every 2 seconds. So what does this number actually represent that it returns? You have to understand, when we talk about our web application, as soon as we write our set time or set interval, it returns a numerical value. And that numerical value is nothing but a timer ID. Timer ID. It's a numerical number, an ID with help of which we can represent that timer. See, when we talk about set interval, it's a continuous timer. Maybe later on, what our intention is, we want to simply go there and stop this timer. So how do we stop this timer? Maybe I want to write some code over there with the help of which I can tell my code, hey, there is a timer going on, please stop it. So how do I stop that? I stop that using a particular function called as clear interval. Now, for the clear interval function, there is a particular method. There's a particular argument which we pass called as timer ID. And that timer ID will is nothing but which timer is starting, which timer has returned earlier when we executed that particular code. You can clearly see Adfar is executing itself again and again. Not sure why, because we have stopped this, I think. Hannah, we have stopped it. But why is it executing it again and again? So let me stop this. But there's some other timer going on. There's other timer going on. So let me go here. So if I stop this, how do we stop this timer? Somewhere there's a timer going on. I have not stopped it, but I think I have, right? So let me close all. So I think no, I won't be. I have to, I think, restart this. Okay, so let me close this. So I could have used clear interval as well, but we don't know what the timer ID of this particular timer is. Otherwise, clear interval is a function with the help of which you can stop a timer if timer is going on. Okay, so let's go here and let me go to August. Done, and then I will simply go open the JavaScript, asynchronous JavaScript. Let me tell you what clear interval is. So open with code. Okay, see, let me go to browser back and let me go and open this particular file with the live server. Try to understand what this number is that it actually returns. So let's go live with this particular function. So I will go over here and let me open the inspect, and in inspect I will go to console, and in console I will simply tell it to execute a particular timer. So let me go here and let me put, after this I will put 10 seconds. Let me click enter. Now I know timer is going on behind it. Timer is right now continuously running. Yes or no? Yes or no? I know in the web API section, timer is right now running continuously, running continuously. The timer 10 seconds is continuously running. Let me go here and let me put, instead of 10 seconds, I will simply go, I will put much more larger number than this. Or even let's do only 10 seconds. Okay, let's do 15 seconds. Let me click enter. I know it returns 3, but I also know there's a timer that's going on. So I will simply use a method called as clear interval, and to this I will pass the number which is 3. Let me click enter. Now when I click enter over there, what does it mean? It means it has cleared the interval whose ID is 3. And which interval is that? That interval is this set timeout. So whatever number it returns, it is the ID of that interval. So that this ID which you receive from it, with help of the same ID, you can actually stop the timer later on if there's a requirement. I hope this number is clear, what it returns. Please make sure you like this video right now and share it with your friends. Okay, I hope you have understood what set timeout, what set interval returns, and what does it actually represent. I hope that means and that makes sense. Now let's discuss one of the most important topics in asynchronous JavaScript. Most important topic, which is called promises. Okay, what do we mean by promises? Is a very important JavaScript function, is a very important web API, not web API, but I would say a structure inside JavaScript. Okay, and what do we mean by promises? Please pay close attention, because this is something that you need to understand very quickly and very importantly. Let's start a very important topic called as promises. I always take a very simple scenario of two friends, because we know that we have heard this particular word in our real life as well. Like I have, when we started this batch, I promised you something. What is that? That I am going to give you the best content that's available on Mern. I'm not sure whether I am doing that or not, but that's what I made promise with all of you. Right? Now, the promise that I made with you, there are two possibilities only to it. Either I will fulfill it or I will not. Either the promise will be fulfilled or it will be rejected, which is real life promises. But let's try to understand the same promises with respect to JavaScript, but with help of a very simple layman example. I always take the same example. I always, because I think it's the best example, because I have myself learned from the same example as well, from one of the YouTube video. Okay, let's suppose there are two friends, me and Adfar is the one friend, and there's one other friend, let's suppose Adil. We are two friends. Adfar and Adil. By the way, my brother's name is Adil as well. So Adfar and Adil are two best friends, and we are staying in a room. We are staying somewhere and we have booked a room where we stay. Done. Now it's time for dinner. Okay? It's time for dinner. We were studying, we were doing our study, and suddenly we remember that we have to do our dinner. And we have not cooked anything. There's nothing that we have cooked. So what I do is I simply tell Adil, hey, please go to the market. Okay. And from the market, please get a pizza. That's what the scenario is. Adil has to get a pizza so that we can eat pizza, we can have our dinner. Adil says, okay, I know in the market there is a food truck, and that food truck, they sell pizza. So I'm going to go there, I'm going to get a pizza. Done. Now Adil starts to leave. Now Adil starts to leave the room. As soon as he reaches the room door, I simply stop Adil. I say, hey Adil, please do one thing. Promise me. What? Promise me. Promise me one thing, which is that as soon as you reach to market, if there is pizza, if there's food truck and they have the pizza, you will give me a call and you will tell me pizza mil gaya. We have a pizza. So that's a promise you have to make me. Promise me as soon as you reach to market, if there's a food truck, you will give me a call, and on the call you will simply tell me, hey, I found the pizza, I got the pizza, and let me bring the pizza to you. That's promise. Second thing is, if there's no pizza at that point of time, please tell me that as well. Now tell me one thing, what's the promise? Promise is to get a pizza. Now there's two possibilities only. Either there will be a food truck, there is a pizza, and Adil will get a pizza, or there's no food truck, or even if there's a food truck, there's no pizza. There are only two possibilities of it. Yes or no? Of course, yes. This is what we mean by promises in real life. But is that what we mean by promises? No. I mean, in JavaScript, no. Promises is not about whether it is fulfilled or not, but promise is a little bit extra step than this. Let's take a little bit more step towards it. I actually say that if you found a pizza, if you went to a market and there is a pizza on the food truck, once you call me, in response to that, I will set up the table. मैं दस्तरखान बिछाऊंगा. I will set up the table and you will come up with a pizza and we will simply eat that. So this is my response to this particular scenario. On the other case, if there is no pizza, you will again tell me that. But to this, my response will be, I will cook rice plus dal, and then we will have the dinner. We will eat then. Now, you guys tell me one thing. Now, whether to set the table directly or to cook rice or dal, what does it depend on? Do you think when Adil leaves to market over here, Adfar knows that I will set the table or I will cook the rice? Yes or no? Yes or no? No, we don't know. I don't know that, because unless and until I don't know whether that promise is resolved or not, I don't know whether I will set the table or I will cook the rice or dal. I don't know that. So it entirely depends on whether I will set the table or whether I will cook the rice and dal. It entirely depends on the response to my promise that I have, asked Adil to fulfill. Yes or no? Similarly, there's one another analogy that we have to take out of this particular scenario, which is that when we talk about this particular scenario, it entirely depends on the data that I am going to get out of this promise. Now, in this scenario, what is the data that I am getting out of this promise, which is pizza? So, pizza is the data. So, if the promise is fulfilled, the data that I will get is pizza. The point is, what Adfar is going to do that with pizza? That's what we have to understand in JavaScript. On the other hand, if there's no pizza, why is there no pizza? We will have some error. Maybe there's no food truck. Maybe there is something else. So whatever the error is, With respect to that adfer, what is adfer, with respect to that error, what is adfer going to do? That's what we need to understand. So it's not about whether promise is fulfilled or not, whether promise is rejected or not. It's about if the promise is fulfilled, what adfer is going to do. It's about if the promise is rejected, what adfer is going to do. It's about if the promise is fulfilled, the data that promise is going to return me, what will I do with that data? How will I extract that data? It's about if the promise is not fulfilled, what the error I will get, what adfer is going to do that error with that error. That's what promise are about. Am I clear? Do you understand this dinner scenario? Do you understand the real example? Let's now relate it with our JavaScript. Let's see a very simple example what we mean by this. Okay. I hope give me a quick confirmation what we mean by promises with help of this simple dinner scenario. I hope that's completely clear. Let me move a little bit forward. Now let's understand the same thing with respect to our JavaScript. With respect to our JavaScript. JavaScript says that I have a particular object within me that you can use, which is promise structure. Done. And with help of this promise, you are going to have two things. That's where I'm going, Govind. You have two things. Either you are going to resolve or you are going to reject, which means promise will either return resolve or it's going to return reject. Now, what is it going to resolve? It is going to resolve data. In our case, pizza. The data is pizza. Or it's going to reject what? Pizza with an error. Pizza with an error. These are the two possibilities that promise is going to have. Either it's going to resolve or it's going to reject. Done. But promises are actually that type of structure with help of which we simply merge our asynchronous handlers. I think there was some network issue. Am I audible, guys? I think I should be audible now. Let me check it. Am I audible now? Perfect. I think I should be audible. Perfect. Okay. Now pay attention. I think I am now audible. Repeat once again. Let me repeat. I said that we have in JavaScript a particular object, and that object is called a promise. It is simply going to complete a task. Either it is going to resolve the data or resolve the promise, or it is going to reject failure. But it is not about resolving and rejecting, although it's about that. But for me, it's not about that. But what is it for then? It is actually that I am going to connect asynchronous operation with its return value. That's what promise means. That whatever it's going to return, पहले से ही in present, I don't know whether promises resolve will return, resolve, or reject. I don't know that because it depends on the operation. An operation can be fetching a data. Now let me give an example. I will fetch a data from a server that is on another part of world. As a user, do I know I will get data correctly from that server? No, I don't know because it is not in my hands. So at that point of time, now the either data will come or it will be rejected. Only two possibilities. So I don't know at this point of time whether it is resolved or rejected. But I know one thing for sure, that if it is resolved, do this. If it is rejected, do this. If it is resolved, handle the data in this manner. If it is rejected, handle my web page in this manner. That's what promise are about. So the promise object represents, if I remember correctly, the MDN definition of promise is that the promise object represents the eventual completion or failure of an asynchronous operation and its return value. So whenever we perform an asynchronous operation, that whether it's there will be a completion of the operation or the rejection, we will simply handle it in a proper manner. That's what we mean by promises inside our JavaScript. I hope this makes sense. Am I clear? Am I clear? Give me a quick confirmation in the chat. Am I clear? Am I clear? Done? Perfect. Give me a quick confirmation in the chat, quickly. Perfect. Another very important point. For me, I have used one very important resource always for learning stuff, for documentation, which is Geeks for Geeks. I would definitely suggest all of you to go there and look at the few definitions that they hold. Geeks for Geeks. One of the very easy resources, one of the very simple resources. This is what Geeks for Geeks says related to promises. Geeks for Geeks says that when we talk about promises is nothing but a container. It's a box. I don't know that what this container is, but I have simply placed a container somewhere and I will use this container for future purposes. That's what Geeks for Geeks says. And I think that's exactly what promises mean. Promises, they say that promise is a container which I have kept somewhere and I will use it for future value. And the container says, I don't have the value right now. I don't have the data right now. I don't know what the value right now is, but I know I will have it later on. I know I will get the data out of it later on, or I know I will get the error later on. And when I get that, when I receive that, this is what I will do. This is what I'm going to do. That's what promises mean. Am I clear? Am I clear? Yes or no? Done? Perfect. Another very simple example. Very simple example. You order something on the internet. Okay. You order something on the internet, which is, let's suppose you ordered a laptop. So you paste, did your order on the internet. You bought the laptop. Until the laptop reaches to you, will you be able to use it? जब तक आपके पास पहुंचेगा, will you be able to use it? No, we won't be able to, because in order to use this laptop, it has to be in front of me so that I can use it. But as a user, don't you already know when the laptop will reach to me, this is what I will do with my laptop? That's why you ordered it. So that's what promises mean. That at this point of time, I don't have the things with me. But once I have things with me, this is what I will do. That's what promises mean. On the other scenario, the laptop you bought, maybe there are some issues in between. Maybe some issues. Now, you also are very clear that if there are these issues, this is how I will approach it. So that my laptop will not create problems in my life, but I know how to deal with it. That's what we mean by promises. And this is theoretical definition. In today's class, we will see simply how promises are created, the structure of it, nothing else. And later on, we will actually see the real implementation of it. So let me create a file with the name of promise.js. In our JavaScript, whenever we have to create a promise, we use, you can say that promise or request, either it will fulfill or reject. Is this promises are not a request, we can say that. No, basically when we perform a particular operation, asynchronous operation means I don't know at this point of time what's going to happen. Later on I will get it. At that point of time, when I get it, when that operation is executed, how do I handle it? Now there are only two possibilities: either that operation will happen or not, right? That's what we need to understand. AK is writing 1 2 4 3. What is that? Now let's pay attention. This is how we define our variable promises. So promise variable is equals to, I will simply say new promise. Now whenever you have to define a promise, this is promise. Okay, new promise. This promise is a predefined word, keyword inside our JavaScript. Now it receives a callback function as an argument like this. So we have a new promise, and inside this promise, we simply callback function, and this callback function in turn receives two arguments. Number one is called resolve, comma number two is called reject. So resolve, comma reject. Now what is resolve? Whether this promise will resolve the data or reject. So let me simply tell it, maybe this promise over there at this point of time simply resolves. What is it resolve? Is resolves pizza. This is what it resolves. Now tell me, if I execute it, what is going to happen? What will be in the output if I execute it? So this is a promise. This is how we write our promises inside our JavaScript. Although you will not use promises in this way in your real web application, very minimum time you will write promises like this, but we will see later on the real implementation of promise. At this point of time, we have to understand what resolve is, what reject is. So what is it resolving? The promise that I created, what is it resolving? It is resolving a string, a data called as pizza. That's what it's resolving. So if I execute this code, you can clearly see nothing is in the output. Nothing, absolutely nothing. Or even let me leave this. Let me not resolve directly. I will simply tell if my, let me go here and let me define a variable a is equals to 10. Then I will simply write my if else logic. If a is equals to 10, at that point of time, please tell my promise to resolve. Resolve what? Resolve my pizza. Else, go over there. Else, please do one thing. Reject no pizza. So the promise that I'm trying to create over there, it's either returning a data point which is called a pizza, or it is rejecting a data point called as no pizza. So if I execute this, what will be the output? That's what my question is. Give me a quick confirmation in the chat. Quickly, what will be the output of this code? Of course, when we try to execute it, you can clearly see it's nothing, right? Absolutely nothing, because it is stored in a variable. So now let's say I'm simply going to say console.log and I will simply try to print promise. Okay. Now I will simply go and execute this. In execution, you can clearly see that right now, since my a is equals to 10, which means the condition is true. So this promise is returning this promise variable. This variable is returning a promise structure from my JavaScript that holds the data which is pizza. So it is resolving the data which is called a pizza. On the other hand, if I simply go like this, okay, which is absolutely not true. So if I try to execute this, now the promise is rejected. The promise is rejected with the error message called as no pizza. So it means that when I am trying to resolve it, a promise can either resolve or reject. It cannot do both. Either it will be resolved with the data, either it will be rejected with the error. Now, you guys tell me one thing. What am I resolving? At this point of time, it's a string, which is of no use to me. But later on, when we try to implement some operations where data is required, for example, you will try to make a request on some API. For example, let me give an example over here. There's a data point on the internet. Let me copy some APIs from the internet. Let's suppose this API. Okay, let me paste it. So there is this API, some endpoint, some website. You can say we don't know what API is mean, but there's some website here. When I enter and make a request on this website, it always gives me a random joke. The joke is which song would an exception singing? Can't catch me something. Whatever the joke is, although it's not funny, but whatever the joke is. Whenever you make a request on this particular data point, it gives you every single time a new data point, new joke. So the joke is something like this. If I click again, it gives me new data point. The point is later on where my promise will be used, that I will make a request on this, and this is the data that I have to extract and display on my website. It's about that, which we will see later on. So at this point of time, it's just to give you an idea that promises is not like you will write your promises like this. No, this is just to tell you how you can extract the data from a promise, or how you can simply extract an error from a promise. That's what it's about. Now, when we say console.log promise, it returns a promise with a data pizza. What are we interested in? Are we interested in promise, or are we interested in what is it resolving? What are we interested in? What are we interested in? The data or the promise? No, we are interested in the data that is being resolved. We are interested in the error that is being rejected. We are not interested in the promise resolved or promise rejected, even though we are, but eventually we are actually interested in what it is resolving, the data point it's resolving, what it is rejecting, the error that it is rejecting. We are interested in that. Now, how do we extract such data points from our promises? For that, we use a method called as dot then on a promise. Whenever on a promise you want to extract what it is resolving or what it is rejecting, we can use a one method called as dot then, and it receives two arguments. Dot then receives two arguments. Both of them are callback functions. Please make sure you like this video right now, okay, and later on comment, although that's not what you guys are doing, but please do that. So what does dot then do? Dot then is a method with help of which you can either extract the data point or you can extract the error. Okay. But what are the two arguments dot then receive? Two callback functions. So let me create one callback function like this, like this. Second callback function like this. Perfect. Right? I have defined two callback functions over here. So this dot then receives two callback functions argument. Number one is this, number two is this. Let me, first of all, I don't know what these callback functions are going to do, but let me simply say console.log resolved. Okay. Console rejected. And at one point, one of the callback functions will be executed. Both will never. Dot then receives two arguments, but one of the callback functions will be resolved depending on what promise is returning. If promise is returning the first argument of the callback function, which is resolve, if promise is resolving itself, then the first callback function is going to be executed. If the promise is returning reject, then the second callback function will be returned. That's why if I try to execute the code over here, you can clearly see it returns resolved. It returns this string. Similarly, if I go write some, let me make it error over there, which means it's going to reject. If I try to execute it, it says rejected. But you guys tell me, are we interested in this resolved string, rejected string, or are we interested in pizza and no pizza? We are interested in pizza and no pizza. We are interested in the data that is resolving. We are interested in the error that it is returning. For that, always remember that the first callback function is going to be executed by dot then if my promise is returning a resolve. We know that. Second callback function will be executed only when my promise is returning a reject. We know that as well. But we are interested in the data that is being resolved. We are interested in the error that is being rejected. In order to extract those two data points, these callback functions receive arguments. You can give them any name. So let me simply say a result. Okay. Now see, I will simply go comma and let me paste the result here. And let me make this condition true. So at this point of time, a is equals 10. So it will resolve pizza. Now the data that you have to extract from that particular promise, which is being resolved, you can extract using an argument called as result, called as anything else, but the argument will be given to first callback function. So if I try to execute this over here, you can clearly see it gives me pizza. So it means now we have found a way with help of which whatever data this promise is resolving, we can extract that data as well as the argument to the first callback function to the dot gen. Second argument, if I talk about this, this is the argument which we will receive if the promise is being rejected. So let me pass error over here. You can give it any name, A, B, C, D, error, whatever, but let me try to reject the promise. So now if I try to execute this, you can clearly see we get no pizza as well. So you guys tell me, you guys tell me, you guys tell me quickly that right now, have we found a way that if any operation returns a promise with the data, on that promise you can extract the data with help of this particular dot then method? Yes or no? Yes or no? Have we found a method? Have we found a way? In a similar way, whenever you perform an operation, if it returns a promise, at that point of time, have we found a way that if the promise is rejecting itself, I can also get that error out of it as well? Of course, yes, we have. Now, you might have not, if you know the JavaScript, you might have not seen second callback function to dot then. You might have not seen that. Okay, you maybe there's a possibility if you already have discussed promises before, you might have not seen second callback function to the dot then, because usually we don't do that. There's one another keyword that we actually use. So number one, another way is I will use on my promise, I will use dot then like this. Done. On the same promise, what I'm going to do is I'm going to use dot catch. There's one another method which we use called as dot catch. Now this dot catch will be actually called when promise is resolved. So this is a simplified version that when we try to execute our promise, if it is resolved, let's implement dot then and pass only one callback function to it instead of two. So I will simply go say console.log my data. On the other hand, the catch that we have, catch means catch the error if the promise is having an error. So I will simply go tell it catch the error over the console.log error. So this is another way. You can use even dot then only, but you have to pass two callback functions, or you can use dot then with only one callback function. And this callback function will simply represent promise that's being resolved. Another catch function, it will receive also one callback function. This will be dedicated to reject over there of promise. So now if I try to execute the same code again, you can clearly see it says pizza. Why? Because that is the data. If I go over here, reject this promise, and then try to execute it over here like this, you can clearly see it says no pizza. So you can use either dot then dot catch. Dot then will be dedicated to resolve with the data that you want to resolve out of it with an argument, or you can simply use dot catch as well to reject, or you can use two callback functions in dot then, depending completely on you. I hope that makes sense. Am I completely clear? Both are same, of course, yes. So this is what we used to do earlier. This is what we used to do earlier when we did not have dot catch method. So we used to pass two arguments in it. But now we have dot catch, and it gives complete idea as well. Like it's readable. It tells you, no, this is how we are going to catch an error. So this is what we will use always, not this method. But I was trying to make you understand, when we talk about dot then can handle both of them. But now from now on we will simply say dot then handles resolve and dot catch handles reject. That's what we are going to do. Okay, I hope this makes sense. So with this, I think today's class was a very exceptional class, I can say. मैं खुद की तारीफ खुद ही कर रहा हूं, but this was one of the very important classes. Okay, so please make sure that if you have joined in now, to please and please, I request all of you to watch the recording again. Because when we talk about our interviews, when we talk about our working in companies over there, this asynchronous JavaScript plays a very important role. You have just understood how asynchronous JavaScript executes its code. You will see now that how this asynchronous JavaScript has made web development fun. Because now we have gone into it, now we will see what promises mean. Actually, this is just the definition of it or the syntax of it. We have, honestly, trust me, we have not understood what promises are yet. Because this is simply how promises are created. That's it. But later on in our next class, which we will have next Saturday, this week I'm not completely available. I have a marriage to attend, and my leg, unfortunately, I have some issues in my left leg today, and I'm not able to walk. But this week we will not have any other class or any doubt session or anything. But next Saturday we will definitely have a class. I mean, coming Saturday, and we will actually understand what promises are used, where promises are implemented, and we are going to discuss some other web APIs as well. We are going to discuss async await as well. We are going to discuss a lot of other things that we need to. Should we join pay after placement? What does that mean? Like companies that teach you, give you some, they make you join a batch. They will teach you, and then you have to pay them 20%, 30% once you are placed. Is that what you mean? I will not today. I guess I think that is shifted to tomorrow, Basu. But I have received the message. I will share it quickly. What does pay after placement mean? Like, what do you mean by that? So is it like you want to join any ad tech where they will teach you, and then you have to pay the fees once you are placed only? Like, it's completely up to you, but I think I'm already giving you the best content, so you don't need to join anything. For placements, you can take help from different people. Definitely. Give your best. I think without such things as well, you can even get a proper company. You can even get placed. Definitely. Right? So don't do that. You can do it. It's completely up to you, but I think you already know a lot of things, right? They will sign a contract with you. Once you are placed with help of them or with not, you have to pay the fees. So let's not do that, right? Let's give our best and get placed on our own, right? See, I'm not asking you to pay anything. I'm giving the premium content, and yet I ask only to put a comment, share it, help me grow this channel, help me grow this batch. Let's make this successful batch. And you are not doing that, right? So you are ready to pay someone else, but you're not able to comment, and you are not able to share this with the rest of the people. No issues. I will try to give you an assignment. वो मैं देखूंगा. Definitely, I will help you with the placement assistance and mock interview assistance. That's a promise, Basu. For sure. Okay. Am I clear, guys? Do we have any questions? Perfect. I think we have completed our today's session. Let me paste the attendance link again. Please make sure you mark your attendance, all the serious students. You mark your attendance, and only 20, these 25, these 27 students are going to receive assistance. Remember that. Doesn't matter about rest of the students. They won't. These 25, 26 students are going to receive assistance in every aspect. Okay. So thank you so much, guys. Bye, everyone. Make sure you submit the attendance, you submit the assignments and everything. So see you guys in our next class. Till then, please make sure you do practice. You continuously submit assignments and you create something good. Now you know Dom, create something good and share it with me. Okay. I will also one other announcement. There is a resume career building session that I have arranged for all of you guys on another YouTube channel. Please make sure that you all join that. Okay. There's a very senior faculty from one of the universities, top universities, who is going to join that, attend that, and teach you a lot of things about it. So please and please make sure you attend that. I'm going to share the announcement for that in our WhatsApp group as well. So please make sure you attend that. Okay. See you guys. Thank you so much. Bye, everyone. Have a great week ahead. Take care. Bye.